right, I'll give quizzes back in a second, but I want to make sure you guys are fully prepared. I'm recording with you guys because y'all usually ask pretty good questions. So I'm banking on you. Now, don't take a picture of this. It's on Canvas. It's in the assignments where I posted all of the answers. This is the first page. This is on Canvas in the assignment. Your assignment was out of 0 points. So if some of you are freaking out you didn't turn it in, I'm not even going to grade it. It's okay. I need you guys to understand what is going to be on this test. It's very straightforward. I know it's a lot of information. I know this is homecoming week. This is your first test. I really want you guys to start off the quarter well. You are going to have one logarithmic and one exponential function from like what very basic on the quiz, where you had to, I gave you points. You have to plug in the points, plot the points, tell me the domain, the range, horizontal asymptote, y-intercept. You guys will have a calculator. So there's no reason you get this one wrong. You can't math wrong if you put it in correctly. Now, if you put it in wrong, that's your own fault. Secondly, you're going to have a logarithmic one where you have to graph. We're going to go over a couple of examples just to remind you, but this is in 3.2, part 2. There's 3.1. There's 3.2. There's videos for part 1s and part 2s. Everything is there, so you guys can go back and look at it. You're going to have condensing and expanding questions. Condense means smush together. Expand means pull apart. We'll do a couple of examples. And then you're going to have to solve. You have to remember what the opposite of log is exponential, what the opposite of ln is e to the x, right? You have to identify the function, get it by itself, and then solve. Remember, you cannot take the log of a negative number. You will have a PERT question. Circle this, highlight it, draw arrows around it. You will have a PERT question. That means the interest will be, everybody get your calculator out and practice this. The interest will be continuous. When the interest is continuous, you use the PERT formula. P is our principal, the amount we put in. So here I have $23,000. Continuously means PERT, guys. I've said it a million times. So then you hit your E button, and you're going to raise it to the interest rate times the time. If your interest rate that I gave you here is 6.3, what is that as a decimal? Yes, 0.063 times, what's the time that I gave you there? 4 years. Practice that in your calculator. Now, guys, if your initial amount is $23,000, you should not put this in your calculator and get like 1.6 bajillion. All right? It should make sense. So practice that right now. 23,000, then hit E and raise it to the 0.063 times 4 power. Gabby, what'd you get?
29,591.
All right, 29,591 point, how much, what's the change? 71? Okay, perfect. If you got that, fantastic. If you did not get that, ask me. Alec, quit. Okay, let me see. Okay, you guys you understand? Everybody see that? Yes. Let's go to some of these things. First thing, I want you to copy this problem. Every single person in every single pre-calc class this year had an expanding or a condensing problem that looked like this on WebAssign. All right, you guys are going to be responsible for all of your problems from WebAssign, from notes that we've done. I just gave you a whole bunch of solving ones to practice those extra. But if you look at this problem, you have to understand what this is asking. First of all, is this already smushed together? Okay, good. So we're going to pull it apart. So are you guys okay with me saying this is the natural log of x to the 7th to the 1/2 power? Where did I get that from? Because it's a square root. And then my division becomes subtraction. So this is ln of y to the 3rd times 1/2 to the 1/2 power. If it was the 3rd root, it would be to what? 1/3. If it was the 4th root, it'd be to what? 1/4. All right. So now this is natural log of x to the 7/2. I multiplied 1/2 and 7/1. And then I have minus the natural log of y to the 3/2. And is this fully expanded? Where does my 7/2 need to come? Needs to go to the front. Where does 3/2 need to go? In the front. So this is 7/2 ln x minus 3/2 ln of y. Everybody had a question like that on WebAssign. So if you turned your WebAssign in and you got either an 85 or higher, if you stopped and didn't do that question, or something like that, make sure you are aware of that. Calculator the whole time. Expanding and condensing. I think there's 2 or 3 of these. Does everyone understand how to condense and how to expand? If you don't, at the end of this, I will go back and go over any of these you want to. Expanding and condensing. All of this has been on Canvas. I put it up last week. Now, for solving, guys, look what I did on every single one of these problems. Do you notice the teal, the blue? I highlighted every single one of my functions. Number 11, I highlighted the e to the x because I said, okay, that is what I'm trying to isolate. I think it's a good idea to do that, and then I think it's a good idea to write somewhere around here ln. Why am I going to write ln? Because that's the opposite. I know at some point I'm going to have to use that. But if you guys notice, all of these problems, this is the only pre-calc step right here. Getting e to the x by itself, if that was a plain old x, you would have still added 14 and divided by 3. There's only one step to these problems that makes it pre-calculus because it involves logs and exponentials. You guys just have to know that one step. But if you're looking through here and you're like, how did we do this? Look at it. I asked you guys to come in here with questions. Look at something like number 15. You can't just cross off ln's. You can't just say, oh, okay, I'm just gonna cross it off. You can't do that. You have to condense it before you can solve. If this was written like this, just say this was a different kind of problem. ln x minus ln of 3 equals 0. There's 2 ways you could solve this one. The one on the left, you have to solve it just one way. You have to condense. What's the second? If I didn't want to condense on this one, what could I do? I could move this ln over here. Why could I do that? Because it's 0. Because now, when you have the same ln on one side and the same one on the other, what can you do? You could cross it off, so it's just x equals 3. That only works when it's set equal to 0. But if you have something like this right here, where it's not set equal to 0, you can condense. You can condense on all of these. Think about condensing means to make smaller, put back together. You absolutely will have a question like this one, like number 20. You had 2 of these on WebAssign, 2 of these on your review. This is a special kind of exponential because it's what? You're going to factor. It's a quadratic. This is the exact same problem if you wrote it like this. 2x squared minus 5x minus 3 equals 0. You would say, okay, what are the factors of negative 6? That multiply to give me 6. Negative 6 adds to give me negative 5. That's going to be x minus 6. No. What are my factors going to be? Minus 3 and minus 2. Okay, my a term is not 1, so I'm going to divide both of these. Do you guys agree?
No.
Okay, so then tell me. That's why I just want you to tell me. What is it? Minus 6 plus 1, okay. So we're going to divide both by 2, yeah? So x minus 3 and 2x plus 1. Now, I'm not going to set this equal to 0 at this point because I'm not factoring a normal quadratic. What am I factoring? An exponential. So I'm going to replace this with e to the x. If you don't like doing it that way, fine. From the beginning, factor it and just put e to the x in front of each parenthesis. But it's just a factoring problem. Now, once we get here, we solve. So you have e to the x equals 3. If I move 1 over and divide by 2, that gives me e to the x equals negative 1/2. What's the opposite of e? So we're going to take the natural log of both sides. When I take the natural log of 1/2, negative 1/2, what does my calculator tell me? Error. Why does it tell me it's an error? Because you can't take the log or natural log of a negative number, so it's not a valid answer. That could happen where you guys get both of them don't work and it becomes no solution. That is a possibility. Don't freak out. Don't think you did something wrong. Maybe recheck your work just to make sure. But when you have e to the 2x and e to the x, don't just get everything to one side. It's a factoring problem. That's it. If we look on this next page, All right, some of these problems, it's, again, another factoring problem. Here, what do I have to do here before I can go ahead and just say, okay, I can just cross off? I see a whole bunch of 7s, so can I just go like this?
No.
Why not? Because there's 3. You got to condense here. What does addition become? Multiplication. Do you see how we smushed it together here? Now you had 1 on one side, 1 on the other. You can cross it out and then just solve. Look at this one. A period asked about this one. If I get 4 to the x by itself, do you guys see how I divided both sides by 12? Subtracted 1, and then we had to divide by that negative 1. Then once it was by itself, then we did the pre-calc step of, ooh, I have to take the log of both sides, and you end up having a negative log in your calculator, so that's why it said no solution. Anything else? 22? Is that what you said? Okay. All right, look at 22. We're going to get e to the 0.5x all by itself. So the first thing I did was divide by 2. So there was nothing else with the e, just the 0.5x. So what's the opposite of e? We took the ln of both sides. And in your calculator, ln of 22.5 gives you 3.113, and then just divide by 0.5. But what can you do with all of these answers? Every single one of these, you guys can plug back in. Before you move on to the next one, you can say, oh, okay, good, I'm glad I'm right. Yes. Sure. Let me look at something real quick. Guys, you see how here I come out with like x equals 3? When you come out with x equals something and you're dealing with logs, what do you have to make sure? What do you have to make sure of with your x value? That it doesn't make the log what? 0. Or negative. No, it can be 0. So if I plug in 3 here, what's 3 plus 5? 8. We're good. What's 3 minus 2? 1. Then we're good. You don't have to worry about going through and checking like log base 2 of this and that. But make sure it does not make the log negative.
Can you do that problem?
Can you do 27?
Yeah, I'll do this one, and then 14, and then 27. Okay, so this is log. Actually, hold on. Did I?
No.
All right. Whoops. Yeah. All right, so look at 29. Both have the same log base, right? Log base 2. So if we go backwards and smush it together, if I have a plus sign in between, do you agree that this would be x times 3, so it gives me 3x? Okay. So then the opposite of log is exponential. So I wrote a big 2 on the left-hand side and put everything in the exponent because I had log base 2. And what you do to the right side, or the left side, you do to the right side. I wrote a big 2 as a base, and then my exponent went to 3. And then this would cancel. And then 29, I just smushed together. Because when you have 2 of the same logs on one side and you smush it back together, remember all of our stuff. Coefficients become exponents. Subtraction becomes division. And then once you get it all concise, then you can undo the log or the exponential. All right, I want you guys to take a picture of this. Last page. Okay, Chris, read that one to me.
Log 2, and then in parentheses, x plus 5, close parentheses, minus log 2, and then in parentheses again, x minus 2, close parentheses equals 3.
Okay, what number is this?
25.
Okay, this is 25. So, I see that I have 2 logs. I have to smush them together. So since they are being subtracted, what does subtraction become? So I have log base 2, and I'm going to put x plus 5 divided by x minus 2 equals 3. Now that I have just the one log, now I can do my pre-calc step and I can undo it. So what's the opposite of log base 2? Okay, so I'm going to put a big 2, and then everything goes up in the exponent. X plus 5 over x minus 2. And what you do to one side, you do to the other. So a big 2, and then I just put 3. You're undoing the log. You don't write the log again. So 2 log 2 cancels. You have x plus 5 over x minus 2 equals what number? 8. So you can look at this one of 2 ways. You could say this is 8 over 1 and then cross multiply and solve. Or you could say I want to get rid of the denominator and multiply both sides by x minus 2. Either way, you're going to get the same answer. And then just work it out. You get x equals 3.
How can we put the log to its
We condensed it here.
Okay,
Because it's the same log base, you can smush it together.
gotcha.
Hold on one sec. 14, what, can you read it to me?
Log is 3, parentheses 2x plus 1 and equals 2.
Like that?
Yeah.
Okay. So the log, there's nothing you can do with it. It's all by itself, right? So what's the opposite of log? Exponential. What big exponent base am I going to write down? 3. So I'm going to write a big 3, and then everything goes in my exponent. And what you do to one side, you do to the other. Write a big 3, and then 2 goes up here. So what happens on the left with 3 log 3? Cancels. So you have 2x plus 1 equals 9, and then just solve. Minus 9 divided by 2. What question?
So,
Jamie? All right, 27. Log x minus log 6. 2 log 4, okay. Now remember, guys, there's not the one specific way to do everything. If mathematically it makes sense what you're doing, that's totally fine. What log base do you guys have on this problem?
10.
Yep, log base 10. If you want to write a little 10 there to make yourself feel better, absolutely go ahead and do so. But I see I can condense on this side because I have log 10, and how could I rewrite this?
Log 10 and then x divided by 6.
X divided by 6, good. Is there anything I can condense on the right-hand side?
Yeah, log 10 4 to 6.
Could I move that? Coefficients become exponents, right? So log 10 of 4 squared. Agreed? Now that I have one log 10 on one side and one on the other, what can I do to it? I can cancel them. So I'm left with x over 6 equals 16 over 1. Now you could cross multiply, or you could say multiply both sides by 6. Right? If you multiply this by 6 and this by 6, x equals 96. And then just make sure that log, when you plug it back in, it does not make it negative. Yes, sir.
can you do the 26?
All right, read it to me.
It's 4 ln 2x plus 3 equals 11.
Wait. 2x plus 3
2x plus 3.
equals 11. Okay. So you want to get ln all by itself. So what do we need to do first? Perfect. Divide by 4. So you have the natural log of 2x plus 3 equals, you can just leave it as 11 over 4. You could do the math right now if you wanted to. Well, what is the opposite of ln? E. So we're going to put a big E, and then everything goes in my exponent. And what you do to one side, you do where? So a big E, and then 11 over 4. When you put this in parentheses, just make sure you do that if you have a fraction. Just so it doesn't like raise e to the 11th and then divide that by 4. But yeah, on the left side here, Alec, e and ln cancel. So you just have 2x plus 3 and then equals whatever that is in the calculator you just solve.
Could you do
29 and 30. If I go backwards, does it erase anything? I want to do these with you. Okay, guys, you're going to have one of these problems where you have to graph the logarithmic, right? You know how to do exponential. You plug in the points I give you. Graphing logs is a little different. It's a little easier. What do you know right off the bat? What is the answer to range every single time you have a logarithmic function? Yep, negative infinity to positive infinity. You have no horizontal asymptote. Guys, come on. You only have a vertical one. So these two things, your domain and your vertical asymptote, go hand in hand. How do you figure out the vertical asymptote? You set the 4x plus 1 equal to what? 0. So this is 4x equals negative 1, so x equals negative 1/4. Right? Your vertical asymptote is at x equals negative 1/4. Now, you can tell me what the domain is right now. Some of you are like, I still don't get it. That's okay. That is okay. But if you look at this, if inside the parenthesis your x is positive, that means your graph is going to exist from the asymptote to infinity, to the right-hand side. If it's negative, it's the opposite. It's negative infinity to f. But if you don't get that yet, you're still like, that's confusing. Okay, fine. Find the x-intercept. How do you find the x-intercept? You set this equal to 0. So log 3, 4x plus 1 equals 0. Now, we know two ways to solve this. We could say the opposite of log 3 is big 3, right? Do that on each side. Or you can, like we said before, think exponentially. If I change log base 3 into an exponential function, this becomes a big 3, and then what happens here and here? They switch spots, right? And this is on the video of this section when I did this. But this ends up being 1 equals 4x plus 1. Now what do? If I'm going to solve, what do? Subtract 1 from both sides. So you get 4x equals 0. So your x-intercept is at 0. At 0, 0. So the two things I need you to graph are the x-intercept, which is right here, and then the vertical asymptote, which negative 1/4 is going to be over here on this side. So where does your graph exist? To the right of that line or to the left of that line? To the right. That's where the intercept is. So you just draw something like that. And then check what we put for domain. Didn't we say it was going to be from the vertical asymptote to infinity, which is where our graph exists? So once you find the two things, you'll be able to tell the domain anyways, but you can tell from the beginning. Like in the second one, change this to a negative. Put a negative in front of here. What's your range for this problem? Yep, negative infinity to positive infinity. There's no horizontal asymptote. So the vertical asymptote, you set the parenthesis equal to 0. Negative 2x minus 7 equals 0. So negative 2x equals 7. X equals negative 7 over 2. So your vertical asymptote is at x equals negative 7 over 2. So what's my domain, guys? Based upon this being negative, it's negative infinity to negative 7 over 2. Good. Now again, if you don't see that, no big deal. We will figure that out here in a second. How do you find the x-intercepts? We're going to say log 2 of negative 2x minus 7 equals 0. So you can either use 2 as a base on both sides, so that'll cancel, and then you have 2 to the 0 power equals 1. Or you could just make it into an exponential function. But if I'm going to add 7 to both sides, I get negative 2x equals 8. So x equals what? Negative 4. So your intercept is at negative 4 comma 0. So let's think about where this is in a graph. Over there. Correct. Hold on. So I have 1. Let's make this negative 2. This negative 3, right? So my vertical asymptote, and here is my intercept. That's where it crosses. And then my vertical asymptote is at negative 7 over 2. That's negative 3.5. Do you guys agree that's between here, negative 4 and negative 3? So where does your graph exist? On the left-hand side through the intercept or on the right-hand side? On the left-hand side, over here. Yep. And that is because it's negative. Good. Well, that's where the intercept is, so it's going to cross through there. But it won't touch the vertical. Yeah.
How'd you make the log disappear for
Because you had log base 2 of negative 2x minus 7 equals 0. What's the opposite of log base 2? A big 2, right? And then everything would go up here. So what you do to one side, you do to the other. So I just wrote it like underneath it right there. That's exactly, it's the same thing though. I just wrote it big. Now, you're going to have one solving the one-to-one property. This is super easy, and it's even easier, only one. It's even easier when you have a calculator. Guys, solving using the one-to-one means you need to get the bases to be what? The same. So how could I rewrite 9? 3 squared, and then you still have your 2x. How can I rewrite 27? 3 to the third, and then I still have my 2x minus 4. Now that the bases are the same, they do what? They cancel. So you have 4x equals. What?
X minus 4.
That is a 4. Did I say 7? It just looked like it the way I wrote it. Yeah. But when I distribute, it's 3x minus 12, right? Okay, so then I'm going to subtract 6x from both sides. Okay. So negative 2x equals negative 12, so x equals what? Yep. So, one of each. But it's very basic. Yep. All right, so now what? How do I do this one? How do I rewrite 1/4? 4 to the negative 1, and then I still have my x, correct? How am I going to rewrite? Well, we'll do that in a second. So I have 8 to the negative 3x plus 2. So what's my common base going to be between 4 and 8? 2. 2 squared times negative 1x, and then I have 2 to the third times negative 3x plus 2. Then we solve. You know, I'm glad you guys both just said 4. I had a lot of people do that on the test. How can you make 4 and 8 the same? You have to use the same base. You just can't say that, well, I can say 4 times 2.
You can say 4 to the first.
No, that's what a lot of people did. They said, oh, 4, they went like this, 4 times 2. That's not 8. That's what? 16. Yeah. Yes. So then we solve. So you get negative 2x equals negative 9x plus 6. All right, so add 9x to both sides. 7x equals 6, so x equals 6/7. Yeah. All right? Okay.